In this video, we will learn how to graph systems of linear inequalities and learn how to determine whether a point is a solution to the system. Let's start with some vocabulary. A system of linear inequalities just means that you're working with two or more inequalities. At the bottom of the screen, you see two inequalities. This is what a system looks like. Now, our job is to find the solution set. So essentially what we want to do is we want to look at any coordinate point and determine if that coordinate point satisfies all of the inequalities. Now this is a little different from when we graphed systems of linear equations, because when we were working with regular lines, we only wanted to know where the lines themselves were intersecting. But if you remember from Algebra 1, inequality signs, less than and greater than signs, incorporate some shading. Less than, you would shade down. Greater than, you would shade up. So here, it's not really about where the lines themselves intersect. It's about where those shaded areas intersect. So a quick refresher on your symbols. The less than sign indicates that you will use a dotted line and you'll shade everything below the line. Less than or equal to means that you'll use a solid line because you're including the points that are equal to the line, and you'll shade down including all the points below the line. The greater than sign, you'll use a dotted line, and greater than indicates that you'll shade everything above the line. Lastly, you have greater than or equal to. This means that you'll use a solid line because you're including all of the points that are equal to the line, and you would shade up to include the points above the line as well. Let's try an example. Number one, we're going to graph the system. That first equation, notice that it's already in mx plus b format, so we can plot those points right off the bat. We're going to begin with b, starting at -3. Our slope, 1 over 2. We're going to rise 1, run 2. Rise 1, run 2. Rise 1, run 2. When you run out of room, go back the opposite direction. Down 1, back 2. Down 1, back 2. Down 1, back 2. So you plot the points just like you would with a normal line. However, we have to really look at that symbol, greater than or equal to, means that we are going to draw a solid line and we're going to shade up. So this means we're including all of the points equal to the line itself, and we're including all of the points above the line. Second inequality is also already in mx plus b format, so we can plot these points pretty quickly. We'll begin with b, so we'll start at -1 on the y-axis. Our slope is 3. We can treat this as 3 over 1, so we're going to rise 3, run 1, rise 3, run. When you run out of room that direction, we can go back the opposite way. Down 3, back 1, down 3, back 1. Now this symbol is just a less than sign, so we only want to include the points underneath the line. So we're going to use a dotted line this time, and we're going to shade it down. So dotted, or maybe a dashed line, and we're going to shade everything underneath the line. So from here down. So we see a lot of blue and red on the screen, but what we really want to look at is in the blue and the red. That is our solution set. Those are all of the points that are solutions to our system. So we're going to take a look at these 4 points over here and figure out whether these points are solutions. So the first point, we're going to call it point A, is 3, 1. So if I plot point A over here, 3, 1, notice how it falls in the section that's red and blue. That is a solution to our system. So is it a solution? Yes, 3, 1 is a solution. Point B, 1, 2. 1, 2. See how this point is on the line? It's on the dotted line though. And remember, the dotted line is because we used just a less than sign. So the points on the line are actually not part of the solution set. So point B is not a solution to the line because it's on the dotted line. Point C is 4, -1. 4, -1. Now this point is also on the line, but it's on the solid line. Remember the solid line we did because it was greater than or equal to. In this case, it's okay for a point to be equal to the line or above the line. So point C, this is okay. This is a solution to the system because it is on the solid line. Lastly, we have point D at -2, 2. -2, 2. Now this is in the shaded section, but it's only in the red shaded section. In order to be a solution to the system, it has to satisfy both inequalities, which means that it has to be in the area where both colors are shaded, where the red and the blue overlap. So point D is not a solution to the system. Let's try another example. This one's a little bit tougher because we do not have lines that are already in slope-intercept form. We're actually going to have to solve for y. So let's take a look at that first one. We've got 2x plus 3y is less than 12. Our job here, we want to get y by itself. So we're going to subtract 2x and move it to the other side. That'll leave us with 3y is less than -2x plus 12. Then to get y by itself, we can divide everything by 3. Then that'll leave us with 1y. Y is less than -2/3 x plus 4. In that one, we can graph. We would start at +4 on the y-axis, and then our slope is -2/3. So start at 4, and then down 2/3, down 2/3. When you run out of room, go back the opposite way, up 2, back 3. That symbol is just a less than sign. Less than means we're only including the points below the line, but not the line itself. So we are going to draw a dotted or dashed line, and we're going to shade it down. We're going to shade everything underneath the line. Do the exact same thing for the second equation. So our second inequality, we have x minus 3y is less than or equal to 6. To get y by itself, we'll move the x over first, so subtract x on both sides. That'll be -3y is less than or equal to -x plus 6. From here, to get y by itself, we'll divide by -3 on both sides. Now that we have y by itself, on the right-hand side, notice it's a -1x. -1 divided by -3 is +1/3 x. And 6 divided by -3 is -2. Now there is one catch here. Remember from Algebra 1 that if you divide by a negative, like we did in this example, you have to flip the inequality sign the opposite direction. This only happens when you divide by a negative. So we are going to switch this from a less than sign to a greater than or equal to sign. So when we draw this, we're going to make sure that we use a solid line, and we're going to shade up. So we'll graph this line starting at -2, and then we're going to rise 1, run 3. Rise 1, run 3. When we run out of room, we'll go back the opposite way. Down 1, back. Down 1, back 3. Here we have a solid line. And we're going to include the points on the line as well as any point above the line. So you can see here as we're shading this, the part that overlaps where the black shaded area overlaps with the blue shaded area, that is our solution region. And any point in that section is a solution to our system. Let's try one last example. This one's a little tricky because we have 3 inequalities. So that first inequality, we have x is greater than or equal to -2. The symbol greater than or equal to means that we're going to include all of the points on the line. So we'll need a solid line, and greater than means that we will shade up. Now this is a little bit tricky of an inequality because notice there's not a y. If it's just x, that means you only go at -2. So we're looking at a vertical line. It's going to go through the x-axis at -2. And shading up, we want to shade upward. We're including all of the x values greater than -2. So we're shading to the right to include. The second inequality, this one's a little bit easier. It's written in slope-intercept form. Y equals mx plus b. We have a less than sign. Less than means we're going to include the points beneath the line, but we're not including the line itself. So when we draw this one, we're going to use a dotted line and we're going to shade downward. So plotting the points, we'll begin with B. We start at 2, and then our slope is -2 over 1. So we're going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. When you run out of room, go back the opposite direction, up 2, back 1, up 2, back 1. We will do a dotted line here. And we're going to shade everything underneath the line, so from here down. So you can see right there where all the blue and the red overlap. But we've got the last one is written in mx plus b format. We have a greater than or equal to sign. So here we're going to include all of the points equal to the line, and we're going to be shading upward. So we have a solid line and we're going to shade up. So graphing this one, we would begin at -4 on the y-axis. Our slope is 1 over 1. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, all the way across the page. When you run out of room, go back the opposite direction. Keep it going. And we said we needed to use a solid line. And on this one, we will shade up. We're including all the points above the line. So we see where the blue and the green overlap. And here in the center, we see where the blue and the green and the red overlap. And over here on the left, we see where just the green and the red, 3 of them overlap. So this is going to be in this triangular section in the middle, where all 3 of those shaded regions overlap. Shade this nice and dark here in the center. You can kind of see that triangle there where the blue and the red and the green all overlap. That is our solution.